Hi students, another video on preparation of aldehydes and ketones, and carboxylic acid we'll take it in the end. This method is basically I am discussing two methods here. One is ozonolysis of alkenes and another one is hydration of alkynes. First we'll see ozonolysis of alkenes. Ozonolysis of alkenes. Ozonolysis of alkenes. Basically, during ozonolysis of alkenes, we take an alkene and we treat it with ozone, as a result of which an alkene ozonide is formed. Now, this ozonide on reductive cleavage in presence of zinc dust. You know, zinc dust is a very strong reducing agent. So, this ozonide on reductive cleavage with zinc dust gives corresponding aldehyde or ketone. Usually when the alkene is di-substituted, we get an aldehyde, and when the alkene is tri-substituted, we get a ketone. But in the double bonded part, if one of the part is, having two alkyl groups and the other carbon having the double bond is having only one alkyl group, then we can get a mixture of aldehyde and a ketone also. So a di-substituted alkene, when the double bond has 1,1R on the double bonded carbon, then we get an aldehyde. And a tetra-substituted alkene, that is when the double bonded carbon has 2R each of the double bonded carbons, then we get a ketone. We just see how to write the reactions. See, we take an alkene. I'm not giving the general reaction. We have already done it in 11th standard. We will directly move to the preparation. Say I take ethene and we treat ethene with ozone in presence of carbon tetrachloride. So we will be getting ethene with O in between here, one oxygen comes here and one oxygen comes here. This way the ozonide is formed, the cyclic structure is formed. This is ethene, and here what is written here as a product is the ethene ozonide. Now further, this ethene ozonide reacts with water in presence of zinc dust, where it undergoes reductive cleavage. This is addition reaction, first step. Now the reductive cleavage will take place, this cut cleavage, and we get CH2O plus CH2O, that we got two molecules of formaldehyde. This is formaldehyde. So we got two molecules of formaldehyde plus peroxide is formed, H2O2. Now the zinc which is sitting over there breaks the peroxide into zinc oxide in water, and this cleavage, the last step, prevents further oxidation of aldehyde to carboxylic acid. In this method, if I don't use zinc dust in the second step, then I'll be getting carboxylic acid and not the aldehyde or the ketone. So this is our first preparation where we prepared formaldehyde. Next, second reaction I'm writing, say I take this same thing I'm writing, C, a double bond C, but here the 2H, I substitute one of the H, and here also I substitute one of the H with methyl groups. So this is a di-substituted alkene. It is having two alkyl groups, that is one alkyl on each carbon. Now I treat it with ozone, O3, in presence of CCl4, so I'll be getting CH3, C, H over here, O, C, H over here, CH3, and the cyclic ozonide is formed. This is but 2 in, and this is but 2 in ozonide. Now in the next step, we take the ozonide and to that molecule of ozonide which we got in step 1, we break it with water in presence of zinc dust. So the cleavage takes place. This is reductive cleavage, and we get 2 molecules of acetaldehyde and peroxide. And then the peroxide is broken by zinc to give us zinc oxide and water, and this prevents further oxidation of acetaldehyde to acetic acid. This prevents further oxidation of acetaldehyde to acetic acid. So that is how we are getting aldehydes. Now see students, suppose over here I substitute these two also with CH3, okay? There also I am putting CH3. Here also I am putting CH3. So this is a tetra substituted alkene, which is 2,3-dimethyl but-2-ene. I treat it with a molecule of ozone, O3, in presence of CCl4, and we get CH3, and here a CH3, and then a oxygen over here. This is 2,3-dimethyl. This is 2,3-dimethyl butene ozonide. Now, in the next step, we are taking the ozonide, which is 2,3-dimethyl butene ozonide, and we break it with water in presence of zinc dust. So this breaks. Since the alkene was tetra substituted, that is 2 alkyl on each carbon, we got 2 molecules of acetone and peroxide. In the last step, peroxide is broken by zinc to give us zinco and water. So we got dimethyl ketone. You know, we can do reverse calculation also. We can do reverse calculation. Reverse. See how? How to do the reverse calculation. Say, question comes, I'm just giving you a question. Give equation for ozonolysis of an alkene. कौन सा alkene मालूम नहीं दिया नहीं, of an alkene कौन सा alkene मालूम नहीं दिया नहीं, alkene मालूम नहीं दिया नहीं, okay? To produce let us make a mixture, acetaldehyde and butanone. Let us take this question, acetaldehyde and butanone, okay? पहला प्रोडक्ट लिखते हैं क्योंकि अल्कीन तो हमें मालूम नहीं दिया नहीं, पहले प्रोडक्ट लिखते हैं. Okay, this is what we want. Okay, let me see. Okay, second step we get the product. I'm writing the product. See how I write the product. Acetaldehyde, okay, and butanone. How I wrote the product? I wrote the product in such a manner that both the oxygen face each other. अब मैं क्या करूंगी, ये मैं नहीं लिखूंगी, ऑक्सीजन नहीं लिखूंगी, बाकी पूरा कॉपी कर रही हूँ. CH3 CH double bond. I didn't write oxygen, I just copied the double bond. C CH2 CH3 CH3. My dear students, this alkene on ozonolysis will give me acetaldehyde and butan 2-one. It's a mind-blowing trick. It's a mind-blowing trick. It's a mind-blowing trick, really. Now we treat it with ozone, CCl4, and I'm getting CH3, CH, O, CH2, CH3, O, and here a CH3. Okay. You can write the name also. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. So this numbering is better because anyway methyl gets position 3. 1, 2, 3. And double bond gets 3. But from here 1, 2, 3. Methyl gets 3 only, but double bond gets 2. So it is 3-methyl pent 2-ene. This is the ozonide formed. The next step, we take the ozonide, this is the ozonide which we got, correct? Treat it with water in presence of zinc dust, and we get this plus H2O2. Last step, H2O2 plus Zn will give me water and zinco. That's the way. This is the way to prepare alkenes. Alkenes? This is the way to prepare aldehydes and ketones from alkenes. So this is the way where alkenes by ozonolysis can give aldehyde ketone. And next we have to go to hydration. And just in the next video I am explaining hydration. Bye bye, take care, love and blessings to all of you.